Okay, so good evening, everyone, and welcome back to another lecture of cloud computing. All right, and finally, we can talk about cloud computing for a change. Okay, so what we wrapped up in the last class was essentially the discussion on live VM migration, the do's and don'ts of live VM migration, how it's useful, the different steps, what are the processes that are involved when you're trying to migrate the CPU virtualization, the memory and file system virtualization, and things like that, right? And then we talked about the fact, and this is one of the most important facts, that kind of leads us to kind of cloud computing in itself, right? Because we were talking about the paradigm shift and such, right? So what are the different computing platforms that was there previously, years and years ago, and how we got to cloud computing and how cloud computing essentially helps us tie up the loop towards the original, two computing paradigms that we essentially need to support our everyday services, right? And what is more important is once we bring all of these different platforms that we studied about together and then bring it under a single roof, what it gives us is essentially the backbone infrastructure for cloud computing. What we have to take care of from here onwards is basically how we convert that into a service model, right? So you have to understand, just to recap, you have all of the hardwares, right? And then that is kind of brought together in the form of computer clusters. Okay, and then you apply the concept of virtualization here. And then on top of that, you apply the concept of virtual clusters. Okay, and then on top of that, you put something that is known as a virtual infrastructure manager. And then finally, once you bring this together under a single roof, this is what is known as a data center, right? But there is still a missing link here amidst all of this, is how does a user essentially access all of these different services that can be supported by this infrastructure that we have created, right? So this is known as service provisioning. All right, and of course, the way cloud does it is that it uses what is known as the service-oriented architecture, or the SOA architecture, that kind of depends on web API calls in order to allow the users or make the users be able to kind of avail the services that is provided by the data center, right? So that brings us to the topics, which is specifically with respect to cloud computing, because cloud computing falls within the domain of a computing paradigm that is known as service computing, okay, because essentially you are providing service as a cloud service provider, or sometimes it is also known as utility computing, okay, where essentially what we are trying to say is that a service provider is providing some kind of utility and the user is paying for that utility, right? Similar to like you draw utilities for electricity, gas, and stuff like that, where you don't own the infrastructure and stuff like that, you just use the service, right? And then you are paying for whatever service that you use. So that notion still remains in this domain as well. If you try to draw the analogy between getting gas supply or electricity supply and stuff like that, and compared to getting a supply here, right, in terms of whatever services that are available, it's kind of synonymous if you think about it, right? Because if you think of electricity supply, you have what is known as an electrical grid, right? Where all of the power is being generated at a particular source. And then through that electrical grid, it is kind of being transmitted across all of the different regions. And then you have these vendors who take that electrical grid supply and then further establish their infrastructure through the lines, the electric wires and stuff like that to get electricity to all of our homes. So if you kind of compare that, and if you think about what is happening, we have something similar, right? So the data center is basically our infrastructure. Electricity is, of course, all of those things are there and stuff like that. But what we need to talk about now is about these electrical wires, how they're established, right? What are the different ways in which you can establish this and provide that as a service to users, right? So that brings us to two different things of cloud computing that is specific to cloud computing is to kind of understand what are the different cloud computing architectures that can be implemented, right? And then what are the different, what we call as service models of cloud computing infrastructure, right? That is, how do you provide those services to your clients, right? So those are the two major topics. And the third topic that we want to cover today is, of course, what are the different design issues and challenges that are present or that needs to be taken into account when you are developing a data center, right? When you're establishing your own data center, right? So this will be similar to like some of the design challenges that we discussed in computer clusters, right? When you're developing computer clusters, what you have to keep in mind. So there are certain notions that you have to keep in mind when you're working with data centers as well. So we will talk about that. And specifically, there will be one discussion, which is a little bit not computing, but more about economics, right? So there's a thing called scale of economics, right? When you're developing data centers. So we have to understand that a little bit to get accustomed to what makes a good data center when you're building one, right? And how it is kind of correlated with respect to cost itself. So those are some of the things that we have to keep in mind. So essentially, we'll go back to the slides whenever we need it. But remember, the primary motivation behind cloud computing, of course, you can say that we want to, increase the resource utilization through resource sharing, enabled by virtualization, blah, 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 and stuff like that. That's all good and well, right? But there is also another spectrum of motivation that is there around cloud computing itself. And that motivation is to make sure that the clients who are trying to use any kind of computing infrastructure, they will be freed from the responsibility of ownership of all of these different infrastructure and all of the accessory or supplementary resources that you need to avail in order to keep the infrastructure running, right? And then on top of that, you don't have to worry about the maintenance and the management of these infrastructures after it has been acquired and it is running, right? So that is another motivation you can talk about, like why cloud computing is important in that sense. Okay, so keeping that in mind, of course, you can do that, but that doesn't mean that all the time when you are working with cloud computing, you don't own any of the infrastructure. And that is why we need to understand the different architectures of the cloud computing paradigm. That is important because intuitively speaking, if somebody tells you that this is the motivation, it might be kind of imprinted in your knowledge that, okay, so that means nobody owns the cloud infrastructure, right? As a client, nobody owns the cloud infrastructure that is owned by the service provider. But that is not completely true. It depends on what type of cloud computing architecture you want to implement. That is going to determine whether you have an ownership entity or not. So that brings us to the three different architectures that you can build for cloud computing platforms, right? So the first one, that is the more well-known one that we know in this day and age, is known as the public cloud. Now here, the initial motivation where it says that, clients don't own any of the infrastructures and resources, this holds very much true, 100% true, right? So you only are responsible for some part of your security, and we will talk about what that aspects are. And then you are only responsible for running your applications and taking care of whatever is happening within the VM environment that is allocated to you, right? So that is your responsibility, essentially. Everything else falls into the hands of the cloud service provider itself, right? So that is public cloud. It is built on the communication platform that is the internet. So internet, not intranet, internet. So basically we use TCP/IP protocol that is already established. So you do not have to define your own protocols as such, right? The other architecture is known as the private cloud, right? So examples for this is basically AWS, GCP is there, Azure is there, and all those stuff, right? And then you have the private cloud, which can be thought of the ones that are developed by HP, right? And private cloud is an area, the architecture of private cloud is something where you have to own, manage, and maintain the infrastructure. And the client isn't the general masses. It is the people who belong to the company itself. So what happens here is that let's assume that HP kind of acquires a bunch of commodity hardware and runs their own software on top of it, right? Applies all of these different concepts that we talked about. That is, they apply virtualization, they have consolidated servers, right? Which is the same as saying there is virtual clusters. And by the way, in addition to virtual clusters, there is also masses of databases that is supporting the storage of virtual clusters, right? And there is a virtual infrastructure manager, which has been designed, not designed, but basically we can use the open source and then modify it based on their needs and stuff like that. So that is essentially the private cloud architecture. And the communication platform for private cloud architecture is the intranet. essentially, we need the intranet because you do not want any kind of outsider access to your private cloud architecture, right? So there is no concept of the public internet. There could be, but it could have very hard layers of authentication and authorization that is kind of creating a boundary between what is the private cloud and what is the outside infrastructure, right? So that is what the private cloud is, okay? And then there is the last architecture, which is basically a combination of these two architectures. And as the name suggests, it is known as the hybrid cloud. So what the hybrid cloud does is the genesis of the hybrid cloud is within the private cloud infrastructure itself, the architecture itself, right? So it begins off as a private cloud, but then there are certain set of services which are missing. So instead of writing those services from scratch, what it does is it basically connects to the internet and then acquires those services from the public cloud, right? So from different public cloud vendors, you can get various different services, right? So if you're trying to build, let's say, a .NET framework, then you can use Azure's platform. If you're trying to develop a web development service and stuff like that, you can either use AWS, GCP, or Azure. All of them supports that and stuff like that, right? So if you don't want to write your own container services or something like that, where you write it from scratch as to what the service is going to be and how you are going to provision that service to your users, which basically is going to be probably your employees, right? Then what you do is you basically connect portion of your private cloud with the public cloud. And you pick and select those services which you are not going to write, but you need for your organization, right? So that is basically hybrid clouds, where you start off as a private cloud. And sometimes when you say private cloud, you can just call it as on-prem. Okay, because essentially the whole infrastructure is on the premise itself and is being used there. But if you think in terms of the public cloud infrastructure, what happens? The data center is somewhere far off from where the clients are. So it is basically not on premise, right? Your clients and your infrastructure are not co-located in the same area, right? So that is what on-prem essentially means, right? So again, hybrid cloud starts off as a private cloud, and then whatever the missing components are in terms of the services that is required, that is integrated from the public cloud itself. And that is where the part hybrid comes into the picture. So as far as the communication protocols go, every communication that happens within the private cloud infrastructure is still the intranet, okay? But however, in order to kind of integrate the services that is provided by different public vendors, that happens through the internet. All right, so this is basically the overview, and we'll talk a little bit more about it in depth of what the three different cloud computing architectures are, right? And this is something that everybody needs to know if you're working within this domain, is that what are the different types of architecture. So sometimes it gets confusing, is because you hear a lot of things like, oh, IaaS, PaaS, SaaS, and then sometimes you hear things like public clouds, private clouds, hybrid cloud. Those are two different things, two different categories within the cloud computing domain. So this category is basically the cloud architecture. All right. And then the other category that you see very often when it comes to discussions about cloud computing are basically the service models. So now if whatever architecture that you use, and the service models are applicable regardless whether you are looking at public clouds, private clouds, or hybrid clouds. It doesn't matter. It's the question about how services are basically rendered or provisioned to users. So you don't have to think in terms of like, oh, if it is a private cloud, then can I do this or not? No, you can do all of the service model regardless of what kind of architectural implementation that you're going after, right? So as far as the service model are concerned, there are three primary service models. And of course, there are variations of those service models, and we'll talk about those variations. But the three primary service models that you're going to find across almost majority of all of the cloud vendors that you will find out there, whether it's public, private, whatever, right? Well, not whatever, the third one is hybrid itself, right? So the first one is basically infrastructure as a service. Okay. Second one is basically platform as a service. And then the last one are basically software as a service, right? And also their popular acronyms: IaaS, PaaS, and SaaS. Okay, and that's what you most commonly see across. Now, what is infrastructure as a service? Well, infrastructure as a service, in its most layman terms, is basically the allocations of the virtual machine architecture that we were talking about earlier when we were discussing about virtualization technology. So what that means is that the cloud service provider have their own hardware, right? On top of that, you have a hypervisor which is running. And of course, I forgot the spelling, hyper. So that's why I just use VMM, virtual machine manager, right? So, and of course, this depends on whether you're using a type 1 architecture of your hypervisor, which is known as bare metal. So that is running directly on top of the hardware itself, communicating through a kernel that rests within the software, right? Or it is a hosted hypervisor, which is, you will see seldom when you're seeing a full-fledged cloud service provider, right? You won't see much of a hosted hypervisor there. You might, depending on the use case, but it's less often, right? And then on top of that, once a user comes, so wherever that our stick figure was, when this person comes and says that it requires an environment which has some kind of CPU capability, memory capability, and storage capability, and requests that service from the cloud platform, right? Where it does the request, we will talk about it in a little bit, right? But assume that somehow the request was able to be transmitted or propagated to the cloud vendor, right? So what they do is the request comes till the point where you have the hypervisor running on top of all these hardwares that are present within the data center, right? And then it kind of instantiates and executes this virtual machine environment. And what this virtual machine environment will consist of is basically the requests that is made by the user with respect to the RAM, the CPU, and all those things, right? And of course, it will be running its own guest OS version. So whatever operating system distribution that the user requested, Linux, some variation of it, right? Or Windows distribution or Mac and stuff like that, okay? And then on top of that, the user can create all of these different containers, which can be running all of the different application stacks that they have either installed or they have predefined when they were requesting the allocation of the resources, whatever that might be, right? So that is basically infrastructure as a service. And now when you're doing infrastructure as a service, of course, storage volumes can be attached to the VMs that are being executed, right? So that is also an option. You can choose to kind of allocate the storage volumes, or you can choose to not do it and do it at a later stage, depending on whether you need storage, which you will most probably need it at some point of time, right? So you can do that. So that is what we mean by infrastructure, because as you can see here in this kind of environment, everything that is being requested by the user and that is being provisioned by the cloud provider are basically computing infrastructure. And what happens within the environment, that is not a care of the cloud. They don't worry about that. It is something that is completely dependent on the users, right? So next question, or the next point, is basically platform as a service. Now, platform as a service has two different operations, right? Two facets of operations. The first responsibility of operation for platform as a service is to implement the middleware for CSPs itself. So what I mean by that is that, let's say you have multiple users or multiple VMs that are running on top of this particular platform that we were talking about as an example, right? And all of these different users will be writing their programs, their processes, and will be creating requests for executing their processes and stuff like that. So these processes needs to be scheduled and executed, right? So think about it in this way. So there has to be some sort of pipeline as the requests are being submitted by the users. That pipeline needs to keep on grabbing those requests and then execute them as it came. Does that make sense? Right? So that is known as a queuing service or a queuing pipeline, where all of the different processes that has been requested or submitted by the user that needs to be executed essentially is being collected and executed in order, right? So that is implemented by platform as a service, but the management of it and the execution of it is handled by the CSP. That is not a user side thing that is going on, right? So what we can say is that QU, I hope this is right. But anyways, queuing service, right? And this is from the CSP's perspective. Then think about it this way, billing services. Right? How much service or how much resources are being used by the user, right? And how do you keep a track of the billing? Okay, so this is something that has to be done by some software somewhere. And that software is basically implemented on platform as a service. That is known as the middleware, right? And then you can think about monitoring services. Within monitoring services, there is a subcategory that is also known as load balancing. Right? So all of these VMs that are running, what happens when one of them crashes? Right? Or how do you know that one of them crashed? For whatever reason, it could be a faulty VM or a faulty hardware. You don't know that, but let's say it just crashed. So who is responsible for keeping a track of that? Right? So that is again from the cloud service provider's perspective, and that is implemented on platform as a service, right? Because these are all different platforms that has different support for the infrastructure that is running beneath. Right? So you have to essentially keep that in mind. But in addition to this, in terms of platform as a service, you can also think from the user's perspective is that if they don't care about the CPU resources, the operating system and stuff like that, they want to run a particular, let's say, process or application that requires a particular environment. Case in point being, let's say they have some kind of artificial intelligence package or stuff like that, or a machine learning algorithm that they want to execute, right? So they need a specific set of setup and environment for that, and then they can execute their application into it, right? So for that, what is provided is basically the platform itself in order to execute those processes, along with any of the APIs or libraries that will aid the execution within that environment, right? So that is essentially given by the platform as a service. And then finally, you have your software as a service, which is basically where the responsibility of the client is the minimum, the most minimum, right? The client has no kind of responsibility, they just do their job here, right? So as you move from here to here, the responsibility of client reduces. Okay, that is as you move from infrastructure to platform to software, the responsibility of the client keeps on going down and down. And as you go from the other direction, that is, as you go here, it's the opposite, inversely opposite, that the responsibility of the cloud service provider keeps on going up. Okay, so software as a service is basically web browser-based applications that can be availed by the clients. So some example of that could be the G Suite, right? So Google Docs, Google Sheets, Google's whatever, there's a bunch of Google out there, right? Gmail is there and stuff like that. Another good example from another different domain is the 365 suite, right? For Microsoft. So all of these are examples of software as a service, and there are many more. And it's not limited to that, but this is like one of the major umbrellas of software as a service that is being provisioned, right? So now there are various questions such as how does this request come and received by the cloud vendors, and how are they routed to the data center that we were talking about? That is, this is the hardware infrastructure that is essentially there, right? So how does this person here sends these requests along these different service model, and how do they get routed back to this location? This should be one of the different questions that you should have, one of the major questions that you should have, right? So that is basically to understand the architecture of the data center itself, right? And what are some of the design issues that are around it, right? So let's look at some of the finer points of this high-level discussion, and let's have that discussion, right? So again, just to keep in mind, not use this, something like this. What is this? Okay, so service-oriented architecture. This is something that we have already discussed. This is essentially how services is being provisioned by the cloud providers to the different users. Okay, The main goal of cloud computing, of course, you can argue about the fact that it kind of enables the support of both high throughput computing as well as high performance computing, but more often than none, right, you will see mostly HTC applications that are supported by the client, right? Interactive applications, burst load and stuff like that, right? But one of the major ideas that cloud enables is the fact that you want to send the computation to where the data is located. Now here, when you think about where the data is located, we are basically talking about data centers. Because if you recall the architecture that we were talking about, the virtual clusters is enabled by all of the different database services that is present again within the data center itself, right? So that brings us to the point that it, of course, improves the bandwidth. And of course, as a result, if it improves the bandwidth, it also improves the latency, right? And the end game is to basically improve the resource utilization, improve application flexibility. How do you improve this? Anyone? What if this was a quiz question? How do you improve application flexibility? What technology enables the application flexibility? We just discussed it in the last chapter, in the last class itself. What was the main?
VMs.
SSI, VMs. In the last class, what was the major talking point? Yes, live VM migration. See, this is the part that trips me all the time. You have live VM, and then migration starts with the M itself. This is the same, I have the same problem with SQLite. You know, this is the spelling of SQLite 3, but when you say it SQLite. So every time when I write it, I write SQL and then light, and apparently that's the wrong thing. Okay, so I don't know what developers think when they come with their naming conventions, but here we go. Anyways, and everybody understands how total cost of ownership is reduced, because we discussed it. One of the primary motivations that clients will not be responsible for the ownership entity of the clouds itself, right? That is something that the cloud service providers are responsible. Now, let me ask you this question, since we're talking about this fact, the total cost of ownership, known as TCO, is, does that mean that the total cost of ownership is high when you implement a private cloud architecture? Or let me rephrase that question. Who is the client of a private cloud architecture? See, do you understand? Do you realize where we are going at?
A company would implement their own private cloud, right?
Right. So does that mean that their total cost of ownership is not improved? Because then they have to acquire everything to implement that, right? So here, who is the client for private clouds then?
The users of the company.
Still users.
The users of the company. Okay. Right. So you understand that the user is not building their own. So at the end of the day, this still holds, but you have to look at it from a different lens in order to provide your argument. That is what is more important. You cannot just universally say that, oh, so in private cloud, the cloud vendor is the client itself, if you think about it that way, right? You build the infrastructure and then you provide it to your employees and stuff like that, or whoever. Maybe you have consultants who work for your company, outside contractors and stuff like that. So they can also be a part of your cloud, and they can use VPN to kind of access it remotely as well, right? Not through the internet, maybe, or maybe through the internet, but that depends on how they're going to implement that communication structure. But anyways, the other discussion is send computation to where data is located. So that brings us to the discussion, the first discussion of the day, right? Can somebody tell me the difference between a thick client versus a thin client? And how do you draw this distinction between desktop computing versus cloud computing? So essentially, the answer to this is also the answer to this. So if somebody asks you this question, you essentially have to formulate your discussion through this, right? So how do you start off with this?
The clients are essentially what we think of as desktop computers.
So how elaborate? That is true. To answer this, answer this.
Big clients have a CPU, they have peripherals, they have all that stuff, and it's all sitting in front of you on your desk. A thin client has the peripherals maybe, but the actual computing is done elsewhere.
That is correct. Somebody else wants to give it a shot? Try to.
Thick clients don't need constant network connections, I guess.
Correct. That is true. So if you're working in an environment where network reliability is not that great, so you can use thick client. But of course, there is a downside to it as well. What is that downside?
Synchronization of data, of course.
Synchronization of data, that is one problem. Yes, that is after the computing is done. But before you can do the computing, what needs to happen?
Transport of the data, whatever you're trying to do.
The transportation of the data, right? And essentially, if you're transporting, let's say, gigabytes and gigabytes of data, let's say if you're doing any of the current day application tasks, right? Any data science stuff, any analysis, large scale analysis, any kind of machine learning algorithm, which let's say runs on images. For example, you're working on a convolutional neural network, right? For image classification. This is a cat, this is a dog problem, right? And your training data set is very huge and you're working on images. If you want to make the scale even more dire, you can think of audio samples and video samples if you want to work with that, right? So the data necessarily will not be located with, you can do it, but if something happens to that, you are essentially the sole responsible entity and you have to answer to your overlords. Essentially, that's the problem, right? So whatever happens, you need to have backup, you need to send the data back to wherever the main data storage is. But if the computation happens on your own machine, so that means wherever that data center is, where the data storage is, the data needs to be sent to the client itself. And the reason why it is called a thick client is because based on the assumption that it has all of the required processing capabilities in order to operate on the data. Whatever logic of application that is going to run has the required processing bandwidth, right? Not the network bandwidth, but the processing bandwidth that is required to essentially run the application. So you can think of it this way, is like, let's say you have a Chromebook. Is that a thick client or a thin client?
What?
A Chromebook.
A thick client? It's both. Because you can run Android apps natively on a Chromebook.
Okay.
It's also a thin client because it's mainly used to access cloud documents.
Right? So you have to think in terms of that. But let's say now you kind of change that and you move towards a laptop. And let's start with the laptop having 4 gigs of RAM. Right? The current generation's computationally intensive applications require much more than that, right? The operating system itself will eat up half of that space. Nothing else will remain, right? When we started with 512 megabytes of RAM, right? And 40 gigs of hard disk drive. That was those days, right?
My first computer had 64K of RAM.
Yeah, there you go. That's like using a sensor node. Right now, sensor nodes, forget about sensors. Right now, cell phones have 8 gigs of RAM right now, right? So we have made big strides from that day and age, right? So that is where the insinuation of the word thick is basically coming from, right? But there are certain downsides of this. But what are the advantages? We talked about the downside that, okay, is going to eat up a lot of network bandwidth. That is going to probably have an effect on latency and stuff like that. And then we discussed one of the advantages, which was basically to say the fact that if you do not have a reliable network connection, right, then as long as you have ensured that the data has been transmitted to your unit, right, your node, then you can do the processing without having to worry about network connectivity at a certain point of time, right? So let us assume that is one of the advantages, all right? But what other advantages can you think of within the realm of a thick client?
Load on the server is less.
Load on the server is less. That is very true. So that leaves the server to handle other requests. That is very true. Yes. So less load on server. But here's my question. If you say less load on server and you're getting where we are going at, the thin client doesn't have the required processing bandwidth in order to execute all of these different intensive applications, right? So the idea here is you take the logic of your code, right? And you send it to where the data is, right? Wherever that is. And essentially, the assumption is in this location, wherever that data is, you have servers that can receive these logic, right? And it has the required resources, the required processing bandwidth in order to execute that process logic on the data itself. So it is kind of, inevitable to understand the fact that there will be load on the server. Is that a bad thing? Essentially, if you think of this as an advantage in thick client, would you say that this, the fact that there is more load on server in thin client?
Depends from whose perspective.
What are the entities here? What are the actors?
So the person who's providing the service
Is that a bad thing for them?
having more load on the server.
They will be charging for that.
Gets more money in their pockets, right?
Can it be a good thing? Is it a yes or no answer?
No.
It's not a straightforward problem. It
It's not a
depends on, yeah,
right?
what the clients are needing. Yeah.
However, you have to keep one thing in mind is that if you are provisioning a service where you claim the fact that, oh, you send me the logic and I already have your data and I will execute it for you, then regardless of what load that logic introduces to your environment, you already promised the fact that you will be able to handle it. Right? So whether or not it is good for them or bad for them, it is something that has been promised as a part of the service contract. So that means it needs to be supported. So what happens is generally, we don't think of this because that is the nature of this paradigm, that the processing is being sent and needs to be supported. Otherwise, the service provider can, at the beginning, say that, oh, I cannot handle this type of applications and run it on my server. So if the service provider knows that they cannot handle that load, they need to be upfront and say that they cannot handle that load. Because essentially, if they cannot handle that load, and if this is a negative aspect on the service part, then everything will start freezing up. Because in order to run this particular application, let's say application X, right? It has to stop receiving requests from other application or other applications will freeze up. That is basically the issue of resource contention. You don't want that in the cloud. We talked about this, right? You don't want resource contention to be present just because of a particular VM, right? So if you know the fact that there is going to be a very resource intensive process that is going to run, it is also suggested on the client's part to take a dedicated space, right? So that means you don't have any kind of multi-tenancy that is present within the VMs, right? Or the infrastructure that is supporting all of the different VMs. Okay, what else? Advantage, disadvantage, thick or thin? Yes.
With thick client, an advantage that you are in full control and own the hardware.
Okay, so there are tips here. Okay. So in thick client, you basically have full control of what?
Your hardware, your resources, yeah.
But how does that help?
You own your application.
You can still control the resources.
You
So
don't own the data,
what I mean, it's my data. I own it.
not if it's on the cloud.
It's my IP.
So if you put your stuff on Amazon's cloud,
You need
do they
to-
not own it?
No,
you
it's
own
still
it?
my IP.
Okay,
If I generate the data, it's still my IP. You can rephrase it though. There are research issues that are there within this domain, specifically with respect to when data is duplicated. Right? So there is a fun, interesting research problem that was there probably like 6-7 years ago. Right? So what happens is in order to kind of increase fault tolerance, right? You need to replicate your data, and basically to keep backup, you need to duplicate it. Right? That's the whole idea of multi-availability zone deployment, blah, blah, blah. So let's say you have a file and that you make 3 copies of it. Total 3 copies. So you have the original copy, it gets synced, whatever strategy you're using, it gets synced. So let's ignore those for a second, right? You're done with your data, you're done with whatever services you wanted, right? And so you delete your application. So this gets deleted. And then the cloud tells you that all the duplicate copies that are there are also deleted. How do you know that? I can tell you that, you give me your data, you're working on that copy of data, you close your account, I tell you, good, I deleted all your data. What is preventing me from retaining the copy of the duplicates? And how are you going to verify that the duplicates were actually deleted? Encryption.
Doesn't mean it's deleted, it's there.
It's an integrity check problem, which is implemented through homomorphic encryption, right? So there is a protocol that is known as homomorphic encryption. So that enables to kind of verify whether there are any additional copies that are present or not, right? So there is a paper, you can read about that if you're interested further in this particular domain, but that was an interesting problem. So you can think of it that way. In terms of full control, maybe you can rephrase it along the lines that you know for a fact that on the hardware that is running all of the different software stacks, there is nobody else that is kind of sharing that hardware. So that way you can rephrase the control as such, because you don't know, let's say within the VM that is running on the cloud, right, whether there are multiple VMs that is supported by the same hardware. Right? So in terms of control, you can think of it that way. But again, remember that this issue can be resolved if you rent out a dedicated space where the cloud is telling you that there is not going to be any multi-tenancy. That's basically the technical word for it, where multiple VMs are running on top of the same hardware, right? So you need to place yourself for your argumentative nature as to what applies, what kind of rationales are you going to use, right? It's not a straightforward answer all the time, right? Security-wise, which is more secure? What do you think? Formulate your argument. Provide facts and support the
I
argument.
don't think either one is more secure, because you still have your data online, so there's still transportation thing.
So formulate your argument.
I would say,
Step by step.
for me, I would say it's a thin client because the data is centralized, and the clients, you can always control what they can see. So you could include security in there. So I would say from a thin client perspective, you have more control of how you want to implement security compared to thick.
Right. But give it a try. Somebody else wants to give it a try. That is correct.
I
But
would say a thin client because, you know, the security professionals that are affordable to AWS are certainly much better than the ones that small companies can afford.
very true. These are all correct answers, but what I'm pushing you towards is to formulate your argument structurally from the very beginning. If you are to evaluate if something is less or more secure, how do you start? These answers are correct, but formulated in a more methodical way. We talked about security, right? Quite a while ago, in terms of like student memory lifespan, that's like ages ago, right? So essentially, how do you evaluate whether some system or some network is less or more secure? There's a technical term for that is known as attack surface. You can talk about attack surface, where basically you can think of an attack surface. The bigger the attack surface, the more chances or the more chances of vulnerabilities being present within your system, network, whatever you're thinking of, right? So you need to minimize essentially your attack surface, right? So the next thing you have to think about is what are your attack surface like? So how these attack surface, or what are the different vulnerabilities that might be present on this attack surface? Now, if you kind of project this information to thick and thin clients, what is essentially the attacker's objective or MO? Well, not MO, but essentially what are they trying to attack?
Tamper or steal the data.
Tamper or steal the what? The data, right? Tampering is one of the ways in which it's the method in which they can attack the resource itself. But the resource itself is what we are looking at is data. Of course, there are other resources, but this is one of the primary resources, right? You can say that the process logic is there. If they get hold of the process logic, they can manipulate that, make it do, rogue stuff on the data itself. Yes, true. That is also true, right? But the major thing is the major currents in the digital world is data itself. You have the data, you have a lot of things going on for you, right? So now if you know this is the first thing, that you have identified the fact that the data is the problem, right? So in a thick client, what happens to the data lifecycle? When you execute your application and stuff like that, what do you do? The first thing that you do as a client is you request for the data, right? And that data needs to be transported, right? So again, going back to some of the things that we discussed already, is that when it comes to securing data, there are two perspectives that you need to always keep in mind. The first perspective is data at rest and data in transit. So now you'll see that in the thick client, your attack surface is quite more compared to thin clients. If you think just from the perspective of the data, because in thin clients, there is no data in transit at all. So the amount of security that you have to kind of enable and ensure is less for thin clients itself. Secondly, now once the data comes to the client, who is responsible for it? To secure the data, keep it secure? The client itself, right? Can you trust the client? You don't know. Maybe they're awesome, but they're human at the end of the day, right? They might leave their computer running, forget to kind of lock it, right? Forget to log out. Something might happen, right? You don't know if there is external hardware access. Some of the computers that are present with the data centers, you cannot just plug in a USB and transfer data from there, right? So those are the things that are beyond the control of your service provider. At that point of time, it is beyond the control of the service provider. You don't have professional security schemes or management or enforcement that is present anymore. So that is a problematic issue. So that again brings in more vulnerability. That again increases the attack surface. The only thing that happens within thin clients is what do? You establish the service, which is a secure connection, networking connection, and then you just propagate your program logic, and then everything else is the responsibility of the service provider who is going to take care of your environment. Right? So as far as security is concerned, from this argumentative logic, you can claim the fact that thin client is a comparatively a little bit more secure than thick clients. There are certain arguments that you can always bring into the picture that, hey, I bring the data to myself, so I have more privacy on what I do. Well, you're going to send it back. So that logic kind of gets to a certain degree a little bit, deprecated or defeated, right? So you can do it, but then you have to keep the data in itself. And if you're doing everything, then just use the traditional IT infrastructure. Why use cloud computing anymore? Right? So those are some of the argumentative logics that you can do. And there's a second discussion here, since we understand all of these resources and stuff like that. There are two notions on how cloud computing is defined. So if you remember previously, when we were talking about the very first class, there are 4 different types of computing that is out there, right? So to remind you all, there is centralized computing, and then there is decentralized computing. Okay. And then there is distributed computing, which is an amazing topic, by the way. And then there is also parallel computing. So here I will assume that you remember the definitions, right? If you don't, you can check it out real quick, right? But there are 2 varying notions, or at least there were 2 varying notions in the community when cloud was, getting in today's language viral, right? So one of the notion was that cloud computing is centralized computing at data centers. Essentially, the logic is based on the fact that here we are claiming that the entire cloud infrastructure is supported under a single roof. So everything that is required is present within a particular physical location, and is within, it's not within a container, I wouldn't say that, but you can think of a housing complex or something like that. Not in the true sense of housing complex, but you get the idea, right? Something like a Walmart or something like that, where you don't have groceries, you just have racks and racks of computers, right? So it's bigger than that. But anyways, so that's one of the notions that scientists came up with. But then there was another alternating notion around this concept, is that it is a practice of distributed and parallel computing over data centers. It's not about centralized or decentralized, but it was more about the practice of distributed and parallel computing over data centers. What are your thoughts on it? What do you think? Knowing and understanding everything that we have discussed up until this point, which notion would you have supported if you were also in the race back? Do you think that it is centralized computing, not notion and all those, jazz, but just centralized computing over data centers? Or do you think it's not about centralized or decentralized, but it essentially is a practice of distributed computing and parallel computing over data centers? Now, again, problem-solving approach, you have to formulate your arguments based on what you know and apply yourself. That is more important, right? So if you want to formulate your argument, apply yourself, then you essentially need to go back and think about all of these different things that we have discussed and what do they give us. Anybody wants to give it a shot? How do you start? Think about it as an interview. Like, you cannot just look at me, right? In an interview, that will call me, like, I will just say bye-bye. And
Can you repeat your question?
which notion do you support? Yeah, that's my question. Do you think CC, which is my informal notation, there is nothing called a CC, it is a centralized computing over data center, or do you think it is not about centralized, decentralized, but it is a practice of distributed and parallel computing over data centers? How do you, yeah, go
Closer
on.
to one, but now in the current paradigm is closer to notion two.
Yeah, but what, how will you formulate your discussions? Like, what will you talk to me about? That's, you're giving me the final answer. That is very good. And that is, yes, to a certain degree, correct. Not certain degree, it is correct. But let's say if you are, discussing it with a potential employer and stuff like that, where do you start off with? How do you show them that you understand your domain to come up with a reasonable argument that supports your answer? What are the different things that are roaming out here? So I see one is this concept. I see one of this. I see one of this. I see one of this, and that's it. That's all there is. So where do you start formulating your thoughts? What is centralized computing?
Well, centralized computing would be getting the practice of well, this is harder than it looks. It would be getting the.
It's a group discussion. You can all chime in. You don't have to wait for him to finish.
Managed by admin group.
Managed by admin group, right? But where are all your resources in centralized computing? Geographically, where are all your resources?
The same.
Does it have to be like that? You see, now I'm trapping you slowly and slowly. But that will unlock your potential. You'll become one of those anime protagonists. You will awaken their true potential. Anybody watching Blue Lock right now? No, can't make the joke there. But anyways, does it geographically needs to be in the same place? Let's say I have one center in Lansing, I have one center here in OU, but I manage it from Ann Arbor. Is that centralized computing? Why not? Single user?
Yeah.
No, it's cloud computing. There is no single user.
For each user, like, technically their data will be in one center. It's not gonna be.
No, it can be across multiple centers.
Yeah.
For fault tolerance, you can always put it across, or you should put it across, actually. What? John.
Okay, I'll give it a try. So I would look at it as if I'm the provider of the service and say I'm providing you centralized computing. The way I would sell that to the client is I would handle all the centralized computing. It doesn't have to be in one data centers. You would be abstracted from that. The data centers can be connected, but all the processing of your data and the task that it involves is on my side, in my, I would say, environment, that I can do all those computing tasks that you need me to do.
Yes, close enough. Let's simplify that. Yes, that is true. You can just, wherever the resources are, you don't have to worry about that. That will be transparent from you being the user, but it will be managed from a single entity or wherever that single location is, right? So that is where the management will be. And that is basically the primary definition of centralized computing. If you think about decentralized computing, you have a different management entity for everywhere, or not necessarily everywhere, but more than one areas where your infrastructural resources are basically located. So if I have a center in California, and if I have a center here in Michigan, then I have a controlling admin for Michigan resources, and I have a controlling admin for California's resources, right? And that is essentially decentralized computing, right? So now, what about, so that takes care of this person here. What is distributed computing and parallel computing? See, I should put this as the true quiz. Make you all write the answer right now in 10 minutes. Whatever you get it, I score you on that. I'll keep you on the toes. What is distributed computing then? And follow up, what is parallel computing? See,
You want me to give it a try?
think about it this way. Simplify, even without. Yeah.
So I would say if the client wants to process a humongous amount of data, I can divide that data and distribute the processing of it in a parallel manner. So I would look at it, describe it that way.
Yeah, you describe both of them. Yes.
Yeah.
So what is parallel computing? What does that even mean?
Means you're splitting the task into several jobs. And
The same thing, right?
The same node, you can run the same task on different computers.
Correct. Right. So you're basically breaking it down into smaller chunks. Each of those chunks have a similar pattern, and you're executing them parallelly. Right. So that way, the sum of execution of the entire job has a lower time than executing the job in its entirety in a serial fashion. So that is basically parallel computing, right? Distributed computing, as from the literal meaning of the name itself suggests, you're distributing the compute capabilities itself. Doesn't mean it has to be parallel in nature. You can make it parallel, right? But essentially you're distributing it across multiple nodes, right? So those can be dependent on each other. They can be independent of each other. That's depending on the nature of the task itself. But the core notion or the logic that kind of encapsulated by distributed computing is you're distributing your compute, right? This is an explanation I gave without even using any of the technical stuff. Just use the literal meaning and I explained it, right? What is important here is me helping you understand how do you approach things that you don't remember or don't know, but how do you break it down step by step and create a formulation which is factual in nature, right? So now if you understand all of this.
Parallel computing, we read about parallel distributed parallel tasks can be distributed as well.
Yes.
And distributed tasks can be parallelized as well.
Depending on the nature of the task, yes. If there is data dependency, then there is a problem. You cannot parallelize, jobs which have data dependency outputs from the subtask. Data dependency essentially means that until one of the tasks finishes and creates its output, and that output is a part of the next job's input, right? You cannot parallelize that. So essentially a lot of the research or the thought process when you're working with parallel programming is to how to redo your program and remove all of these dependencies within the program. So that
If a task cannot be parallelized, it cannot be distributed,
you can still distribute it, yes.
Yeah,
You can still distribute it. You just communicate back to whatever the result is to wherever the other task is running. Right? So essentially now, if you understand this, can you relate everything now back to the infrastructure that you're working with? And then relate it back to the initial answer that was given, that notion 2 is what is supposed to be. Can you tie up all of these theory? And so essentially the last concept that is kind of stays here is what is a data center. Now we talked about this. This is what a data center is. Which part of this component is important for you to finish up your argument? Virtualization is the technology that is enabled, but the infrastructure is basically virtual clusters with database. And if you remember the diagram, we had the physical clusters, then we had all of these nodes, right? And then essentially you can distribute your tasks across nodes, which need not be a part of the same cluster. So even though geographically things are in the same location, right? There is a notion of distribution that is present. right? And as long as the tasks can be parallelized, that is basically the caution or the condition that you're giving, right? Then you can essentially do both distributed computing and parallelized computing, right? And where the admin entity is, if whether it is centralized or whether that is decentralized, and when we say centralized and decentralized in the sense of cloud computing, that means we are saying for each availability zone, there could be an admin entity, or there could be an admin entity for the entire region. We don't care about that, right? That is not something that we are concerned. So that is why in the current day and age, right now, in the present, Notion 2 is a little bit more applicable. That doesn't mean that there is no discussion about centralized versus decentralized. It's just that the impact of that is much less than the second Notion itself, right? So we talked about this. We talked about public clouds, private clouds, hybrid clouds. You can check out some of the final details, right? There is no final details. We actually talked about most of it, right? But this is what kind of encapsulates everything that is there for all of the different architectures, right? So if you look at this is better. Yeah. Okay. So you have your private cloud. That's where it starts. You always have to start thinking of it in terms of private cloud. When you make the services available over the internet, a private cloud can become the public cloud, right? So that is why we discussed all of the infrastructure problem first before we started discussing cloud computing, because without that, cloud computing is nothing, right? So you can build a private cloud. The private cloud, if then it is connected to all of the different public cloud providers that are out there, right? And some of the well-known ones that we are familiar with, this is no longer there anymore, okay? This is now completely within the umbrella of GCP. There was a difference between the SaaS PaaS part and the infrastructure part previously, but now it is all within a single branch, right? But when you connect this, that is when you connect a private cloud through the public cloud, part of the operations remain private, and then you are only using the services within the private cloud, then that becomes the hybrid cloud infrastructure, right? And if everything is available over the internet for the common masses, all of the different services that you have to provide as a vendor, that is known as the public cloud itself, right? Anytime a user needs to submit a request, they submit it through an API, which API is typically going to be a web browser interface, okay? Or it could be a command line interface. There are two options that are available to you in order to submit your requests, all right? And then once the request is received, there is a platform as a service, okay? Essentially, that is known as the middleware of any cloud vendor, which handles the request and then sends it back to the data center. So now what you have to understand is how the request is routed within the data center itself, right? And that is one of the most important part. So this is the layer of a data center. So the boundary of the data center starts at this location itself, okay? And then you have two different layers. One of these layers is the middleware layer, which tries to figure out that where that request needs to be routed. And then it sends to a particular location within the data center, which is a bunch of virtual clusters and hardware resources on top of which the virtual clusters are basically built on that, right? So the lowest layer are basically all your physical resources. So these are your racks, server racks, containers that consist of rows and rows of servers, right? Without any kind of peripheral devices. So that is basically your hardware infrastructure. On top of that, you have your switch that interconnects all of these different racks together and to the switch that is supported by load balancers and ends layer 2. Once that is done, these switches are connected to what are known as access routers, and then you have the gateway routers that is at the very top of the layer that kind of bridges two networks together, where one network is the internet itself and the other network is whatever is there within the data center, right? So when it is received or when the user accesses the UI, sends it, then it is received by this gateway routers, sent to the access routers of a specific data center. Then it is sent to the switch, which is supported by load balancers. Load balancers are generally software that figures out where to send the request to, and to also make sure and monitor that a particular location or a particular cluster of your data center does not get overloaded, right? And then you have some intermediary layer of switch that is just to connect all the different racks together. And then finally, at the bottom, you have the rack itself. Make sense? So you have to keep this in mind. Okay, and then supplement this diagram that you have. There's no figure, but basically the type of cloud platforms to it. Okay, so essentially, remember this. This is important. All right, and as far as the nodes go, okay, majority of the nodes that you will find here, and when I say nodes, these are all rack spaces, but you can virtualize them, and that's how they become nodes essentially. Majority of these nodes are going to act as compute nodes. And that is what you're going to see when you're going to avail infrastructure as a service from any public vendor. But a lot of nodes are not accessible to the public, and the role or the basically the designation of these nodes are as control nodes. So they monitor what the other nodes are doing. They make sure that everything is going well. And of course, there are some backup nodes as well. In the instances that some of the working nodes fail or some of the primary nodes fail, things needs to move somewhere, right? So there are also backup nodes that are present, right? Okay, so as far as the cost goes, we talked about the fact that the total cost of ownership, right? So, okay. So as far as the cost goes, okay. So when it comes to cost, the basic comparison is always between classical computing and cloud computing, is the fact that you have some fixed cost. To just boil this down into the most simplistic way for you to remember, right? There are two things that you have to remember in terms of cost. There is fixed cost, and then there is variable cost, right? This is the most easiest way to remember the total cost of ownership, right? Fixed cost, you have to get your hardwares, right? Buy all those racks, buy all of those different computers that are there. You have to buy any kind of software that is necessary in terms of, let's say, OS distribution. Linux, you don't have to buy, right? But well, everything else under the roof, you have to basically spend money, right? There are also certain softwares that are responsible for management. If you're not writing your own from scratch, then you have to buy. People don't buy because there are open source softwares that are available in order to kind of dispense all of the different sectors of the services that data center needs, right? But you still need some money involved in software itself. Then what are fixed costs? Okay, so that means location. I will put as location, leasing and renting the area. What else?
Basic hardware and software.
Basic hardware and software is here. Location, then
Network.
what network?
And you have to pay for the bandwidth.
What's the other name for it? You have to pay for a service or a commodity. What is that? Yeah, just say that. Internet. Okay, you're paying the ISP. What else? What are all these machines running on? What are the fuel? Electricity. Thank you very much. What else? If you have one room filled with just computer servers or CPUs, there's going to be immense heat.
Yeah.
Cooling.
So in order to dissipate the heat, of course, electricity is tied up to it, but you have to get air conditioning unit, you have to use coolant and all those stuff that is associated with it, right? You have lights and stuff like that. But what else? Think about it. There is another niche area that is a part of the fixed cost.
Administration.
Facilities.
Facilities we can put inside of location, right? But a location, what do you need to do? You need to keep it secure,
maintain
physically, and maintain it as well, right? So you need staff, right? Salaries of the staff, right? So we could just say staff. So you need to look after the salaries of the staff looks after it and stuff like that, right? And what are variable costs? Usage. Now, so this is an interesting area. Well, not as interesting if you realize what is happening, is that you can have a basic charge for the internet, but you can also kind of argue that if your usage goes above a certain peak point, then you will pay more. And if it stays less than that, then you pay whatever the regular service is. So your usage will be one of the variable costs. What else? Think in terms of scalability. When you think in terms of variable cost, you have to always connect that to scalability, right? Scalability going up or down, whatever that case may be, right? So what are some of the other things that you might need? and that will cost you. You might need more service if your peak usage goes up. You might need more data storage if the volume of your data goes up. So you need more hardware commodities that can support all of these things. So these are some of the different variable costs that are involved. Now, the beauty of it, and the reason why cloud computing is more favored is because if you look at the traditional IT infrastructure or IT computing, whatever you want to call it, right? The costs that are involved are both the fixed capital costs as well as the variable costs of the operation, right? And then in cloud computing, you just have the variable costs. And that is why cloud computing is known as pay as you use models, right? You're just paying for whatever you're using. You don't care about the ownership entities of the commodity and the resources that is needed to keep the data centers running, right? So question for you to think about is, we were talking here with respect to classical computing, which can be IT computing, right? The traditional IT and cloud computing. So now if I further break this down, and this is what we talked about, that this is the traditional cost model for IT, and this is the traditional cost model for cloud computing. What happens? Where would you pitch private clouds? How would you formulate your discussions? Should private clouds go here or should private clouds go here?
More traditional.
So are you saying it's leaning to traditional IT infrastructure? What question should you have in mind if I ask you this question?
Who manages the infrastructure?
I would,
Perspective are these charts developed?
The client's perspective, the users.
So then if I say private cloud, which one should it be?
I think it's traditional IT, because the company's architecting their private cloud, and
Right.
the users are using it.
So who is the user? So that goes back to the previous question. Who are the users in private cloud?
The employees, but they don't care about the fixed or variable costs. It's the company that cares about it. So if a company developed their own private cloud and deployed it, they have fixed costs, but if they use cloud computing like AWS to do all their stuff, then it's variable.
So what's the answer? That's just one argument. That's a good argument.
I think it's cloud because at the end of the day, the users are the employees, so to them, it's cloud computing. But in this case, the provider is not like Google or a big company, it's just the company itself. So it's still cloud computing.
As it works.
Both in the sense?
See, they're owning the equipment, everything, hardware and software dedicated to them. And
Mhm.
in the cloud computing, we have dedicated servers or big nodes specified to the organization, like dedicated clusters coming to that concept.
So what does both mean?
Both private clouds, both in both ways it is coming in both ways. The traditional IT that are using fixed, hardware and software, dedicated to the organization. And even in cloud computing, we have the concept. Both under both this
Well, at private cloud, anyway, we have to do this whole setup thing. But it's in the organization, so who is paying for that thing?
So it kind of goes back to how you think of it as a client, because if you look at this discussion, right, if you think in terms of cost model, when they say pay as you go for each service provided, you essentially understand that this narrative is from the perspective of the client. So how you establish, because all of this is about removing the ownership entity, the management, the maintenance of the infrastructure away from your clients. Clients just focuses on the service. So when you are defining the cost model of a private cloud itself, when you are analyzing the cost model itself, of course, there will be a fixed cost that will be involved, because if you are doing the analysis for the organization itself, then that means the organization has to procure all of the infrastructure. Also keep in mind that there is a cost that is involved in maintenance as well. There is a cycle for every hardware that you buy, like in 3 to 5 years, is going to depreciate, right? So the amount of performance that you get from initially when you bought, a good example are these phones, right? So that you use a phone, regular usage, in 3 years, your battery will not support it anymore, right? It will be discharging way faster than how it used to be. The same goes for our computing resources as well. And as years progresses, the type of softwares that are being designed, right, and the amount of computations that it needs is also increasing. So what you were using 10 years ago will not be able to support whatever applications you're running, even the basic ones, right? So those are some of the things that you have to keep in mind. Now, when you're doing the assessment, you have to ask yourself, for whom are you doing the assessment? Right? So typically, there are discussions when it comes to private cloud versus using public cloud, especially for startup companies, and they always go for public cloud. And the reason why is because of this. Because you can always choose to build your own cloud if you are very concerned about security and privacy issues, right? If you never want the data to leave your domain, you have to go with private cloud. You don't have any alternatives to that, right? Or you can do a hybrid version. But if you go there, then your cost model changes, right? Because you're doing the assessment for the organization, and you cannot do that argument that, you know, I have my employees, so I don't incur any of the fixed costs. That is not completely true, right? Because from an assessment of a total cost of ownership perspective, you have to think in terms of what costs are incurred by the client for whom you're doing the cost model analysis, right? And here, that is the organization itself. Okay, so typically, if you go work for a startup company who doesn't have a cloud solution that is implemented, and this is a very common line of job, right? There are a lot of companies you will see, they tell you, we will develop the cloud solution for you. The first line of action for these companies, and if you work for a company like this, is to do the cost model analysis, right? Figure out what is your current cost using the infrastructure that you're working with, and what the cost will be for the cloud itself. So there you can discuss or have a discussion that if you set up your own cloud, what is going to be your cost? If you set up a hybrid cloud, what is going to be your cost? And if you go to the public cloud, what is going to be your cost, right? And then for each of those architecture, once the cost model has been established, then you have to have a discussion on security and privacy and stuff like that, right? To see like what is beneficial and stuff like that. Okay. All right. So design objectives. So from the analysis perspective, if you're doing private cloud, you have to take into account the fixed costs. Because the cost model is basically what costs are incurred if you're setting up your cloud environment, right? So if you're setting up a private cloud environment, that means you have to acquire the resources.
So does that mean it goes under the traditional?
The traditional IT, the costs that are involved in traditional IT, that is something that will also be there for the private cloud as well.
But in that case, like, if you're looking at it from the provider's perspective, then public would go under.
No, we are looking at it from the cost model analysis perspective. Who are we doing the analysis for? Are we doing it for an entire organization, or are we doing it for individual clients trying to establish their infrastructure? Does that make sense?
So technically, why would you be doing it for the organization? The whole
Because
point-
a private cloud has to be set up by an organization.
But that's like their choice. They're the
So-
provider in that case, they're not.
So if you remember, when we're saying who are the clients in the private cloud domain, the provider themselves can be the clients because they build it for themselves and then they use it. All of them who are working in that company, that organization, are using that particular solution as well. Does that make sense? So there is no fine line. Right? The confusion is arriving from that is that because there is a cloud model that is associated with it, it has to be different from traditional IT models. That is not entirely true, because if you set up your own infrastructure, you are at the end of the day responsible for acquiring and managing all of those things. And that kind of revisits the cost model for traditional IT. Does that make sense? So you will see most of the startup companies who do not have a lot of, money in order to set up their services, and in order to be quick about setting up their services, they always go for public clouds. So in that particular scenario, when you do this cost model analysis, then the distinction is between traditional IT versus the cloud computing model that we saw here in the slides, right? But there are further discussions that is beyond cost that needs to be taken into account. So for example, are there any legal issues for hosting your data on somebody else's platform? If there is a problem like that, let's say health records and stuff like that requires very strict guidelines with respect to privacy regulations and stuff like that, right? So if whoever's platform that you are trying to migrate to, right, do not provide you that guarantee, you cannot go there. But if your organization is very big, right, and you still have to establish a cloud-like environment, so that means you have to establish your own IT infrastructure in order to build that cloud environment. Because at the end of the day, if we see this, what is cloud computing built on? It's an IT infrastructure, right, which is just virtualized and then provided as a service over the web.
But in cloud computing, like anyways, the base code is not going anywhere.
No, it's not going anywhere.
But the provider is handling, so the user is not.
Right, but the provider is not the user in public clouds. You see, an organization, even if we think of the organization as the user, let's say in order to keep some semblance of uniformity, if you just think of an organization as the user itself, right, to have that uniformity, then in public clouds, the organization is not acquiring any kind of IT infrastructure. So the cost model analysis is from a user's perspective. Yes, that is true. But what if the user is the organization and they want to set up their own computing model, which is what private cloud is, right? Then the fixed cost is something that has to be borne by the users and not somebody else. You see, so that is just like the subtle distinction that we are talking about at the time point. Okay. All right. So we'll stop here. We'll finish cloud computing this Wednesday online. All right. Well, not cloud computing, just this chapter itself, right? So we can move on to AWS after that. All right. So we'll stop here. And I will see you all next class.